So today we actually have two different learning goals. One of them is being able to use ratio boxes to help you set up proportions. And then, of course, we already know how to solve them, but we want to make sure we get a good setup. Knowing how to solve them is part of it. The other part is making sure we know how to set them up ourselves properly. And then using proportions to problem solve. I'm going to tell you right now, and I'll remind you again when I give you the homework, this ratio and proportions worksheet that has a front and a back. Any problem that is not a true or false one, and we're going to do some true or false practice on here also, but any problem on these, which if I'm not mistaken, I believe it would be a total of 14 problems, I want to see the proportion model used for solving. I know there will be other ways to go about solving them, but I want you to practice setting up proportions to problem solve, and then solving that proportion. Then you can pick which method of work you're going to use to show solving the proportion. But I want us to get used to being able to use the proportion model for solving word problems, okay? So we're going to that's one of our learning goals, is being able to set up a proportion to problem solve. Okay, so let's start with this first one here. We have Mr. Jeff, who's got some money that he's dividing between John and Jack. The ratio is 4:2. John got the smaller amount of $1,256. How much did Jack receive? So when we set up a ratio box, notice I already have the box set up for us and some titles. John and Jack are represented in this problem. We were given some ratio values. We're given some actual numbers. Whatever you're eating needs to stuff, okay? So we are going to plug into this ratio box into the appropriate locations and then make a decision from what we have in there. Can we set up a proportion model to help us problem solve? Now, one of the things that's nice about a ratio box is it sorts out everything for you, and that's where you can put your labels. Then when you set up your proportion, because you've already taken care of the labels in the ratio box, you don't have to put them in the proportion model, such as we did. Let's turn over those notes that we did last Thursday, 1.8. Look back side. What did I say you had to do when you set up your proportion? Put labels on 2 of the pieces, 1 of the pieces, whichever pieces you feel like, or all of the pieces. How many of them? All of them, all 4 pieces in the proportion. Both numerators, both denominators need to have labels when we're setting it up. Well, if we do it in the ratio box, then our labels are going to be in that, and we can just go right to setting up our proportion and not have to include the labels. So what do you think we could say for John and for Jack for ratio numbers? They said the ratio is 4:2. So we could treat those as dollars. This is money. So for one of them getting $4, the other one gets $2. Which one's going to get $4 while the other one gets $2? Jack gets, how much does Jack get? He gets the 4. How do we know that? Because, yeah, here's what this gives it away right here. John got the smaller amount. So we're going to say that John is getting the 2 in the ratio, and Jack is getting the 4 in the ratio. What else do we know?
John's total was $1,256.
Yeah, we know that John actually got $1,256, and we're solving for how much Jack got, right? So X dollars. So our labels are in our ratio box, and all we do is we set up a proportion that will help us problem solve this. So what's a good comparison that we could make? For every $2 John gets, how much does Jack get? 4. Well, there's a comparison right there. For every $2 John gets, Jack gets 4. That is the same as what? 1/2. No, we're problem solving. We need a ratio that's going to have some of those other numbers in it. We're not simplifying this. We're problem solving. We need to solve for X. Jalen?
1,256 over X.
Yeah. For every $2 John gets, Jack gets $4. When John gets $1,256, Jack gets how many dollars? John's represented upstairs in both of them, Jack is represented downstairs in both of them, right? Okay, go ahead and solve that. You can use whichever method, but I'm seeing all kinds of crazy ways. Some people are trying to solve proportions that don't make any sense. So let me see. Don't erase, Cheyenne. I don't want to see it. Cross products? Anybody using cross products? Okay, so on one side we need to multiply the 2 and the x. On the other side, doesn't matter which sides we use, but the 2 and x need to be a product. Or yes, they need to be multiplied and get a product. The 4 and the 1,256 need to. So we should end up with 2x equals, oh, let's see, is it 5,024?
Yes.
Am I right? Okay. And now we're going to do what to both sides? Divide by 2. And after we divide by 2, x is by itself. And we should know what x is equal to. What does x equal? Grace? 2,512. And those are
$10.
dollars. And who gets this much money?
Jack.
Okay, so this is Jack, isn't it? I'm not going to put mine there. I'm going to run out of room. I'm going to put it right here, I guess. So Jack receives $2,512. Okay, does that answer make sense? Tell me why it makes sense. Paul?
It is about twice as much as John gets.
Okay, but I don't want to do any math.
And I'm not.
Yeah, you are. But you're right, it is about twice as much, if not exactly twice as much as John gets, right? I will agree with that. Emma?
It's more than what John gets.
It's more than what John gets, and is Jack supposed to get more than John?
Yeah.
Yes. That's the first kind of reasoning we gotta have. We gotta make sure that we have a reason, and then maybe the next line of reasoning would be, you know what, yeah. Jack should get twice as much, because 4 is twice 2, isn't it? So he should get twice as much as John does, and that is exactly twice as much as what John gets. Okay. Okay, I want you to start filling in that ratio box with the numbers that are given in that problem. Start filling it in and get some labels. You know how that ratio 4 to 2, we said those could be dollars in both cases, the 4 and the 2. What can we do with these numbers? Okay, so the good thing about this one is the labels are kind of like right there, aren't they? Okay, so somebody tell me what should I put in where? You think Jayden, give me one of them. Where do you? What should I put somewhere?
I do the actual number for girls. Three. Yeah. Never mind.
For the actual number for girls, put what?
Never mind.
Oh, never mind. Oh, okay. Give me something, Paul. You gotta get it somewhere.
Put the rate or the numbers for the ratio.
Okay, where do you want me to put them?
If I'm right, it's girls and boys, right? And it follows the same order of way the numbers are.
It does.
Okay, then it's 3 to 7.
Okay, so 3 would go in the row with the girls and 7 would go in the row with the boys, right? Okay. Anybody have something else I can put in here that's gonna help? Oh, Cassie?
The total amount of children is 90. Okay, so that's gonna go in the actual numbers total row, okay, 90 total, okay.
So we have 3 knowns so far. What's the unknown in this row that we need to find? The actual number of girls. Okay, so what should we put there for that?
X, because we don't know what it is, okay.
So do we have enough information to set up our proportion now? Would we set up a good proportion with these 4 pieces of information?
Yes.
Okay, so give me an example of a proportion we could set up with just these 4 numbers that you see right there in front of us. Emma?
3 to 7 is equal to X over 90.
3 to 7 is equal to X over 90. So 3 girls, because remember that's in the girls part, 3 girls compared to 7 boys is the same as comparing,
Testing, we all call system.
is the same as, oh wait, let me go back. 3 girls compared to 7 boys is the same as comparing X girls to 90 boys and girls mixed together.
No, wait, never mind.
Yeah, I think that's gonna work. Kenzie?
Do we have 3 to 7 to 7 to
Every 3 girls there are 7 boys, we can add it together, that means in a group of 10, there would be 3 girls and 7 boys. Because now what could we do? Now what would be a better setup? Do you want to finish that, Kenzie? What would be a good proportion?
3 over 10 equals X over 90.
3 over 10 equals X over 90. Because 3 girls compared to a total of girls and boys is being compared to X girls total of boys and girls. Now we're comparing likenesses, aren't we? So now we can solve this. We can either use cross products or another method that you use to show your work. Okay, anybody want to offer up what would be a good thing to do in this one? Grace?
Cross multiply.
Cross multiply. Okay, give me the cross products.
10x equals 90 times
Okay, 10 times x equals 90 times 3. That's 10x equals 270. Next move would be divide by 10. So 10x divided by 10, 270 divided by 10. What does x equal? 27. And those are what? Girls. Okay. Does it ask how many boys there are?
No.
No, so we only have to answer that one question. Does our answer seem reasonable? How many boys would there be? 63. There should be more boys than there should be girls, right? According to the way the ratio started in the beginning. 3 to 7, girls to boys, less girls than boys. 27 is less than 63. Or 63, we said, right? Okay, was there a faster way to solve this one?
Probably.
You just don't know it always, do you? I bet there's somebody in here who used it. Anybody just rename the fraction 3/10 as 90ths? No, this is one of those that would actually be fairly easy to do that too. 10 times what is 90? 9. So couldn't we also in this one just do this? After we have our proportion set up, say 10 times 9 is 90. If I take the denominator times 9, I have to take the numerator times 9, and presto, the answer is whatever 3 times 9 is. Get the same answer, don't we? So sometimes they're friendly enough to just be able to rename the fraction as what the other one has for, we can take it and rename it so it's going to incorporate the answer, the given number in the other one. Questions? Okay, in this next one, we're talking about a math book that is made up of core content pages, so pages where you're learning the skills you have to learn, and advanced content pages, in other words, the pages that they're going to throw in there to challenge you, make you think even harder on those skills. And altogether, this book is supposed to have 450 pages, and of course, they give us a ratio in there. They say a ratio of 7 to 2. Did it say which one they give more of or less of, so that helps us? Okay, then we just go with whichever order they gave it in, right? So core and advanced content. Okay, so when you're setting up your own ratio box, are you here with me, Trevor? Cool. When you're setting up your ratio box, you're gonna want a column that shows ratio numbers, okay? And you're gonna want one that shows actual numbers. And sometimes you're gonna need a total, and this one looks like you need a total row, so that could be your bottom row. We're gonna total across the bottom row. And then we have those two rows in here where we have core content, pages. This is where we do our labeling, remember? Core content, pages. And this book has advanced content pages. So now we would not have to do our labeling in the proportion model because it's really getting done right there in our ratio box. And we're able to set up a proportion from our ratio box. Okay, fill in some information in there. Fill in some information in that ratio box. Given that we have a ratio of 7:2, a book needing 450 pages in it, and we're supposed to find out how many pages of each type of content. So we're actually going to have two things to solve for, but we'll start by just solving for one. Kira, you got this for me?
7 in the content core pages and 2 in the average content pages.
In the advanced content, okay. A couple of numbers we can throw in there. Is there somewhere else we can put some numbers? Emma?
You could add 7 and 2.
You can add 7 and 2 together and get 9, so that for every 7 pages of core content, there are 2 pages of advanced content. So in 9 pages, that's what we can count on. In 9 pages, 7 of them will be core content, 2 will be advanced. Okay, what else can we put in this table? What else can go in there? Jayden?
450 in total.
450 for the actual total. Do we have enough information to solve for one or the other right now?
Yeah.
Yeah, we do, don't we? So which one do you want to solve for first? Core content? Okay, then we're going to put an X up here for the actual core content. What proportions could we use to solve for core content pages? Jalen?
7/9 is equal to X over 450.
Okay, 7/9. So the core content pages compared to the total. Core content pages compared to the total. That should do it, shouldn't it? Okay, go ahead and solve that. Solve that for X, please. If we use cross products, would that be the setup? 7 and the 450 getting multiplied on one side, doesn't matter which side. And the 9 and the X getting multiplied on the other side, it does not matter which side. Okay? 7 times 450, what is that? Grace? 150? Thank you. What would we do next? Divide by 9. Divide both sides by 9. What do we get for X?
X equals
350. Okay, and what?
pages.
We're not going to just say pages, we're going to be more specific. We were solving for content pages. We have to be more specific. What were we getting? Because now they asked 2 questions in this one. And so since they asked 2 questions, we have one more thing to do, right? Let's make life easy. What could we do to make this easy? What could we do to make this easy, Kathy?
We could divide 450 by 9.
Divide 450 by 9? Why would we do that?
To get 50 and then multiply 50 by every 2 numbers over.
So 9 goes into 450 50 times, and then we would multiply it by what? which number though? We're looking for solving for advanced content, so we'd have to multiply by 2, wouldn't we? Yeah, that's one way to do it. That would be one way to do it. Divide 450 by 9, let's say there's 50 pages in every part. We need 2 parts for the advanced content. Jaden?
Where you could subtract their 50 from 450.
Yeah, we have the total number of pages, which this kind of seems like almost the easiest thing to do, doesn't it? 450 total. Take away the 350 that are core content. How many are left to be advanced? Yeah, 100, which 2 times 50 would be 100, wouldn't it? So 100 advanced content pages. Okay. We've answered both questions they wanted from us this time. Way to work to support them. Okay? I like your thought process. Okay, anybody have any questions about using ratio boxes? Okay, I'm not going to require you to use them on your homework, but I'm going to require you to set up proportions to problem solve. So you can either use the ratio box method to get a good proportion setup, or you will do like we did on the backside of the lesson 1.8 notes that we did on Thursday, where we wrote the labels in our proportion setup. Every piece in that proportion would need a good label on it so you can make sure you have good comparisons going on, okay? So no questions on this. Okay, let's go to the backside then, please. Okay, true or false questions is what we're going to do back here. True or false and why, in other words, support your true or false answer. 3 to 4 is equal to or is the same as 15 to 20. 3 to 4 is the same as 15 to 20. True or false? What do you think? True. Okay, we're all going to say true. Okay, what's your reasoning?
If you divide 15 and 20 by 5, you get 3.
Okay, so if you take the 15 20ths and try to make it look like it's 3/4, Emma says divide 20 by 5, that gives you 4. If you take 15 and divide it by 5, that gives you 3. 15 20ths does simplify to 3/4. Okay, there's one way. What's another way we could also? You don't have to show every way, but you have to show some way. What's another way that went through somebody else's head when they looked at this? Paul?
Common like what you did with fractions, the common, okay, just,
Do you want to rename 3/4?
I'm trying to explain what
Common denominator?
kind of, 20 what number can you multiply to get 15 20s?
Oh, so what number can you multiply to get 20ths? Wouldn't that be a thought?
Yes.
To get the denominator 20. What would you take times 4 to get 20? 5. So you would take, and then you would have to do the same thing upstairs. And 3 times 5 is 15. So again, they're equivalent, aren't they? Okay? That's another thing we could do. What else should hold true if this is a proportion? Because that's what 3/4 equals 15 20ths is, isn't it? It's a proportion, ratio equal to a ratio. What property did we say will hold true for a proportion? Turn over to the front side of your notes, maybe. What property will hold true if it is a proportion?
It could be A to B, B to A, like you switching around the steps.
Well, wouldn't that, A to B is not the same as B to A. No, that's not true. I don't think that's just A to B could be written like a couple more ways, but did we not do something called the cross product property? Do these have those notes? Right there in the middle of the page, cross product property. If you take A times D, it's the same as B times C. Didn't we have something like that? So in other words, if we took this 15, or this, let's write it the way it was given, 3/4. We took this 3/4 equals 15 20ths. And we did cross products, they should be equal to each other, right? So 3 times 20 should be equal to 4 times 15. What's 3 times 20?
60.
60. What's 4 times 15?
60.
You sure?
Yes.
Okay, convince me. You don't say that because 4 times 5 is 20 and carry your 2. No, convince me that 4 times 15 is 60. Sometimes you guys just put it down because that's what it's supposed to be, and then that's not enough. Paul?
Because 2 15s is a 30 and there's 4 15s.
2 15s is 30, and we need 4 of them, so 30 plus 30 is 60, yeah, so it is 60. Okay, thanks for convincing me. Okay, we have all kinds of ways that we showed that it is true. Okay, let's do the next one. 2 to 5 is equal to 20 to 80. False. Okay, well, we'll put false and then we'll prove that it's false. Okay, this one's false, huh? So give me something that you're gonna show to support that it's false. Brent?
So it's 2 over 5 equals 20 over 80. And find out that 2 times 10 equals 20. And then 5 times 16 is 80. And 16 and 10 are not the same.
Yeah, we're not multiplying by the same thing up and down, are we? Okay, good. Maybe another way that we could show that this is false. Jayden?
Cross product.
Cross products, or we could do cross products. We could have 2 over 5 equal to 20 over 80, and we could multiply 5 times 20, and that should be equal to 2 times 80. What's 5 times 20? 100. What's 2 times 80?
160.
160. Does 100 equal 160? No, those are not equal to each other. Okay, anybody have another way that they'd like to share with us how we can disprove that they are equal to each other? Okay, Paul?
No, I probably, no.
You want to change your mind?
All I did was I looked at it. It can't.
Why can't it be?
Well, first off, it's 2 and 5. Those cannot run in any equal way, except for when they're being multiplied by themselves. So, 2 times 5 is what.
Okay. So in other words, 2/5, can that be simplified? Anybody think of any way to simplify that? No? Okay. How about 20/80? Can that be simplified? To what? 2/8? Okay.
1/4.
Even 1/4, right? Okay. Well, they don't have the same denominator though, so we can't compare them. We can't say, if they don't have the same denominator. So then maybe we would still have to rename these so they have the same denominator. Maybe we made life a little easier for that. So what would be a common denominator here?
20.
20th. So 20th. How many 20ths is 2/5? 8. 4 5s and 20. So 4 times 2 is 8. 4. How many 20ths? How many times is 4 going to 20? 5. So 5 times 1 is 5. Now we can compare them and say, no way. They are not equal to each other. So there might be a variety of ways to check to see if they are. Okay. How about number 6? Oops. How about number 6? 2 to 5 and 20 to 8 are equal ratios. 2 to 5 and 20 to 8 are equal ratios. True or false? Emma?
False.
False. How come?
If you simplify the 20 over 8, it's more than 1, and 2/5 is not.
20 over 8, she says, is simplified. Could you tell me what it is simplified?
2 over 4.
2 what?
2 and 1/2.
2 and 1/2. Okay. And then you said 2/5. What's that?
2/5.
2/5. Okay. Is 2.5 equal to 2/5? No. So not equal to. There'd be one way. Come up with another way to disprove that these guys are equal to each other or are equal ratios. Can we always do cross products? Absolutely, we can. If all else fails, we can always do cross products. Or 2/5 equals 20 over 8. 2 is going to get multiplied times the 8. 5's gonna get multiplied times the 20. 16, 100. True or false?
No.
Not true. Okay, there's another way. Or there was like Emma was trying to say back here, this one, that's greater than 1. This is less than 1. We can't have numbers that are opposite sides of 1 equal to each other, can we? Okay. So you'll be doing some of that in your homework also. So just the true or false is not going to be enough. You have to support it like we were just doing back here. Okay, you are going to need a sheet of loose leaf paper, and I'm going to be handing out 2 papers to you. So while you're handing out loose leaf, I'll hand those out, and then we'll talk about what you need to do.